Welcome back to my channel, guys. This video is a brief overview of some concepts that Saito makes possible, and it's one of the goal of this video is to highlight why I am excited about Saito. And it's going to be like I'm not going over every detail here, and some of the stuff that I'm going to be saying is hypotheticals. They may not be built into the Saito code, but it opens up possibilities for Saito themselves or others to implement these ideas into blockchain architecture in the future, bringing about the different possibilities that this type of stuff can bring into the blockchain space. This kind of Saito architecture could bring. So keep in mind, I'm not going to go over every detail about Saito, but this video is going to just go over the concept of scaling and just some general ideas so that, in a general sense, people who come across this video who are interested in Saito could think about some of the traditional blockchain problems and what Saito can answer. So we're going to start with is just to some background so we could understand what it is Saito is answering in just one of the components of Saito, which there's other components such as paying people who contribute work to the network, versus other systems. But what I'm going over just in this concept video is the cycling component of Saito. So Bitcoin history, what is, we're going to go over some concepts, right? So what Bitcoin history is basically the blockchain data, right? So people who, just to give you an overview of the general concept of blockchain, it is nothing but a record that spans through time. That's what these blocks are. And these are transactions. That's what this is. It's data. And it's about 1 to 4 megabytes in size. And it's about 10 minutes per block. So it is a ledger. And it's a bunch of computers agreeing to this ledger, which is people's accounts. So that's all a blockchain is it's data. And this data is compensated by the transaction fees. And it's added to the total blockchain. And it's added at about 52 gigabytes a year, right? So, and that's this blockchain keeps growing and growing and growing. So much sense that this blockchain is going to go on for eternity. It's going to go on forever. Right now, the Bitcoin blockchain is 364 gigabytes, roughly in size. Over a human lifespan, the Bitcoin at its current pace, if nothing else changes, it'll roughly be 4.16 terabytes in size. That means a node that wants to have all of Bitcoin's history, a node that carries all of Bitcoin's history will need 4.16 terabytes at the end of a human lifespan. So it's not a big deal with Bitcoin. You can see that 4 terabytes, right now it's 364, and I'm saying the human lifespan is 80 years. Technology is going to be a lot more advanced, or humans are screwed. But I personally think that we're going to be a lot more advanced in the future. And you could look at how technology is progressing. And I don't personally think that this 4 terabytes will be an issue. And Bitcoin, so for Bitcoin, this blockchain size is not the biggest deal. And, there's second layer things, etc., that can help scale Bitcoin. But what you have here is this Genesis block, and the Bitcoin blockchain is going to grow forever. And the reason I do think it's important for Bitcoin to hold its history forever is, over multiple lifespans. It is, as far as we can tell for now, until, society becomes whatever we're going to become, like a hive mind or whatever in, 100, 200 years. I don't think humans are going to look the same in 100, 200 years, but, I'm just going to stick with what we know right now. So what is important is over lifespans, if Bitcoin has records, if someone leaves an account for their ancestors, they can still use it 200, 300, 400 years later, so long as this blockchain persists, so long as these nodes acknowledge the historical, the blockchain. Let's say 3 lifespans later, it'll only be roughly 12 terabytes, which in 3 lifespans, 300 years or so, or, around 240 years or whatever, it won't be, our technology will make it to where that's not a big amount of data. But the point of what I'm saying here is for Bitcoin, it's not really a problem. It's not the biggest problem. But for Ethereum, it is. For scalable blockchains, for blockchains that have more than just transactions, the ones that have smart logic, it's a massive problem. Ethereum is growing about 4 terabytes a year, or about 320 terabytes over lifespan. Now you can see that actually could be a problem. That might, and there's even evidence of Ethereum nodes that don't carry the Ethereum history. They drop off the history. And so you can, but there are some that support it, and it's being subsidized right now. And they're trying to scale this by opening shards. And if you divide this by, like, let's say there's 16 shards, which I think what they're going to do, then this number will be divided by 16 over a human lifespan, because you'll have 16 shards of data. But that introduces more complexity. That means there's potential more attack vectors, etc. So it is what it is. Some nodes are now, some nodes are dropping. Okay, so now let's introduce Saito and how Saito might potentially answer these things. So Saito is a cycling blockchain. It cycles. And this isn't necessarily the way that Saito is going to be built, but it's a potential use case for Saito. So you have this blockchain persisting over time, but instead of just being a straight line, so let me explain how the blockchain for Saito works so that I can explain how it could be used to scale blockchains. So by making Saito a loop, what happens is this last block gets thrown away, or this last block gets thrown away, and the next block becomes the genesis block as Saito cycles. So it cycles through this, and once it does a full cycle, it starts deleting a block. So delete, 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 delete. And so what it could do is we could say, hey, when Saito completes a complete cycle, it reports in from this block as the genesis block, and it does a cycle, and then it reports the data as everything has changed into the new block. So this is a certain size, this Saito blockchain cycle, one cycle, and it could be 1 terabyte, which could mean that, but Saito hopes to scale blockchain, and I think it will, because it could allow for unlimited amount of transactions to be added to this cycle to complete this 1 terabyte. So let's say it's 1 terabyte, and this is a variable block size, right? These are variable block sizes. So this amount of time to complete a cycle doesn't have to be fixed. The data is fixed. So if it's 1 terabyte, you could make it theoretically that this whole entire cycle completes in a day. So it could be a throughput of 1 terabyte of data a day, which would be an immense amount of throughput compared to Ethereum or Bitcoin, an unfeasible amount. And at the end of the cycle, you simply make it a 1-day block for that variable completion of the Saito cycle. That means that it would be as if this blockchain right here is doing, a terabyte a day, but in reality, it would only be whatever the data transfer of this is, the growth of this blockchain, which is the permanence layer. So this would be the temporary layer, and this would be the permanent layer. So that's not necessarily the way Saito is going to be built, because you can actually have permanence within Saito because it has something called a rebroadcast fee, which means that if something wants to persist, if there's some data in here and it wants to persist another Saito cycle, all it has to do is pay for the transaction to be broadcast in the block, and it starts over. It exists in the new Genesis block. It exists for another cycle, because it rebroadcasts itself to the cycle to start over. So, as the pin moves here, like of the completion, it's like, oh, it hits this block, and it sends it over. It rebroadcasts itself to stay in the blockchain, so that it could exist for another Saito cycle, whatever data you need. So this data is kind of like a rent. It's a temporary rent. It's almost like a RAM, in that a financial RAM of rental of temporary data that needs to be kept available. And when it's no longer needed to persist, it can be broadcast into the permanence record. So what this looks like is you can see the green is persistence, and the purple here is data that's thrown away. It's data that's not needed. And here's an example, roughly. These are all of these concepts aren't necessarily how they're going to build things, but they're what Saito's technology could potentially do to the blockchain space. That's why I'm going over this concept, is to understand that I think that Saito has proven that the trilemma in blockchain, this trilemma of scalability, of being decentralized and scalable, like the crypto trilemma that says that blockchains either have to give up something to become scalable, they have to give up decentralization to become scalable, is wrong. Because this Saito model proves to me that you can have decentralization if you throw away some data that you don't need. And here's an example of how that would work. So here is some like people, and this is a let's say this is one blockchain. Oh crap! This is let's say this is one block cycle, and these are transactions between the cycles. So these are individuals in the blockchain, and there's 10 units of account, right, or 10 units of currency. So there's a set of transactions. And these new guys have these new orders, and then they send around tokens, and so all of these events are data that are recorded in the blockchain, and then you have this final result. So this purple section could be an analogy for this is analogous to the Saito cycle. Obviously all of this is oversimplified, but you can see this purple would represent the data that exists in the temporary layer, the Saito temporary layer, and the only thing we care about is this final result. So it could be a snapshot, transitory. This is something that is fleeting, and then snapshot. So a lot of data can be thrown away. So it would be theoretically to where you could even grow at the pace of Bitcoin with massive amounts of throughput of applications. It could be any data, and all you care about is the end result at the end of the day, or whatever amount of data cycle that you care about. And you could build applications with these considerations. So, as long as the data needs to persist. So this is data that is temporary. It only needs to persist for some period of time, and it could even pay for several cycles. However long this is. If it's 1 day, then it pays for 365 days. It could pay for a whole year. It could pay for 10 years. It could pay for 100 years. Whatever the rebroadcast fee is expected to be, to persist in the temporary layer. So it's not even though this is temporary, it could persist for a very long time if you just fund whatever the data is that you want to exist in this temporary layer. So you can have applications like that. So ultimately, you throw away all this data, and you only care about the end result. And so it looks like this, you see the same result, and you can have some kind of checks in place to make sure everything's good or whatever. But this is basically, just to give a general sense of why Saito is a big breakthrough. And blockchains are going to become scalable. They're going to be easy to use. You're going to be able to use blockchains, which means you'll be able to use any financial instrument on your cell phone, super lightweight, fully decentralized, fully scalable at hardware level speeds. And that's thanks to this project with the cycling blockchain concept. And the cycling blockchain concept allows, unlimited throughput because of the rebroadcast fees. And I would have to get deeper into that on how that works. But the idea here is that there's some data that we don't care about. And even if we do care about this data, we could pay to stick around in that the Saito cycle, in the whole, whatever the cycle is for Saito to complete one cycle. And it could be 1 terabyte. It's not an amount of time, it's amount of data. So if it's 1 terabyte and the blockchain gets a whole bunch of transactions, that 1 terabyte could be a day, it could be even a second or whatever, All right, so hopefully this helps you understand how Saito is extremely interesting to think about for the future of blockchain, and why I'm personally excited about it, and I want to watch it. And I think other people will take this technology eventually in the future, whether it's the Saito team build out. Now, you could, Like potentially you could build out a blockchain with Saito shards where each one of the shards is a Saito cycle of temporary catch data, you know, where the data exists temporarily, you know. So you can see how these blockchains are going to become business monsters and they're going to eat the world. Blockchain is going to eat the world. This technology is going to help it. And all these concepts that you hear up until now is that blockchain is not scalable or whatever. You know, there's Bitcoin maxis that don't understand that this technology is happening this way. Dude, like the world is changing and this technology is going to be there, the front of this. Like blockchain is, to me, this is a breakthrough and it's going to, and it's just it has me excited. All right. So, if you like this kind of content, please like and subscribe. And I hope to bring out knowledge and present it in an understandable way. Hopefully I did a decent job at making this a little bit, the Saito idea, the Saito cycling blockchain concept, a little bit more understandable. All right, later guys.